Hey guys, today we're going to learn about the complex number. Now here we have ax squared plus bx plus c equal 0. Now this is the standard form of your quadratic equation. Now typically we see complex numbers as solutions to a quadratic equation. Now a complex number is when you have a real number plus or minus an imaginary number. Now, imaginary solutions are the result of when the discriminant, which is what is underneath the square root of your quadratic formula, equals to 0. As a reminder, we learned the quadratic formula in Algebra 1 and Algebra 2, and the quadratic formula is as follows. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now it's important to remember that a, b, and c represent the coefficients that are attached to your x squared, the x, and then your constant would just be c. Now just as a reminder, you can only use the quadratic formula when your quadratic equation equals to 0. Now just to see how this works, here we have the quadratic equation 3x squared minus 2x plus 4 equals 0. I am going to use the quadratic formula to see what my solutions are. So remember, this is the format we're going to follow. So just in case, in this particular quadratic equation, a is equal to 3, b is equal to negative 2, and c is equal to 4. So I'm just going to plug in these numbers into my quadratic equation, my quadratic formula. So x equals negative b, so b now a positive 2, plus or minus the square root of b squared, negative 2 squared is 4, minus 4 times a, which is 3, times c, which is 4, and everything is over 2 times 3. Now we're just going to work this out so we can get our numeric answers. So 2 plus or minus the square root of 4 minus 4 times 3 is 12, and 12 times 4 is 48. All over 6. And this then equals to 2 plus or minus the square root of negative 44 all over 6. Now we have to simplify this, and I put here that it is easier to separate the fraction so that you may simplify your answer much easier. So here we go. What that means is that I'm going to put everything over 6. So we have 2 over 6 plus or minus the square root of negative 44 all over 6. In order to keep simplifying this, first of all, I notice that I have this radical, and inside the radical is a negative number. Now we have learned that inside of a radical you can never have a negative number. This is an imaginary number right here because it's not real. That doesn't exist. So what we do is we just make it positive and we bring out the imaginary unit, which is I. Now we're going to see if we can simplify this square root. So I'm going to do that off to the side in a different color so that we don't get confused. So we have the square root of 44. Now you think of two numbers that multiply to give you 44, which are 4 and 11. Now, in order for you to remove a number from the square root, I think of the square root as a house. And in your house, you're not able to go out unless you have a friend. So what we do is we got to find friends. And friends are numbers that are the same. So this 4 and 11, they're not friends because they are not the same numbers. So we keep breaking it down if we can. 4 can be broken down to 2 and 2. These are friends. So the 2 gets to go outside of the square root. The 11, however, the only two numbers that multiply to give you 11 are 11 and 1. So there are no friends for 11, and 11 will have to stay by itself. So now I'm ready to rewrite my answer here with a simplified square root. Additionally, we're going to try to simplify these numbers. 2 over 6 can be simplified to be 1 over 3. Plus or minus, I said that the 2 is going to go on the outside, so 2, and the 11 stays inside, all over 6. And again, now we can simplify this 2 over 6 that's on the outside. So my final answer would be 1 over 3 plus or minus the square root of 11 over 3. Let's have a look at how we can further simplify these radicals. So here we have what the imaginary unit is defined to be. I is equal to the square root of -1. And if that's the case, then I squared is equal to -1, because if you square both sides, then the square root would end up canceling out. So if we're trying to simplify some of these square roots, whenever you have a negative inside of the square root, just make it positive and bring out I. So for this number, this is the equivalent to I square root of 7. And if I could simplify the square root of 7, I would, but there's no two numbers that multiply to give you 7 that are identical. So this would be my answer here, most simplified version of of the square root of -7. If we look at the square root of -18, same thing, I make it positive and I bring out I. And now let's see if we can simplify 18. Two numbers that multiply to give you 18 are 9 and 2. And then 9 is further broken down to 3 and 3. So these are my pairs. The 3 can go outside of the square root, but this 2 will have to go inside. So my answer would be 3, the I that's already outside, square root of 2. Over here, we have 3 times the square root of -25. Now again, I can make this positive and bring out I. 25 is 5 and 5. So that means that there are no other numbers, so we can completely get rid of the square root. So we have this 3I on the outside, and the square root of 25 is 5. So what I have to do now is multiply. 3I times 5 is 15I. For this one here, we're going to again make this positive and bring out I, and think of two numbers that multiply to give me 12. Two numbers that multiply to give you 12 are 4 and 3. And then 4 can be broken down to 2 and 2. So these are my pairs, and this 2 can go outside with the -2I. So this is what I have. We have the -2I that's on the outside, the 2 that I'm bringing out on the outside, and then the square root of 3, since the 3 has to stay inside of the square root. Then I can just multiply this -2I with the 2, which gives me -4I square root 3. So this is the definition of a complex number. A complex number is when you have a combination of a real number plus or minus an imaginary number. All complex numbers are written in this form, A plus BI, where A is the real number and then BI is the imaginary number. So the imaginary number always has to come afterwards. So as a reminder, I have here what is the correct format and what is the incorrect format. 5 plus 3I is the correct format for a complex number, where 3I plus 5 is not. So always the the imaginary part goes at the end of the complex number. So for example, for A, we have the square root of -8 plus 3. So first I'm going to simplify this square root and bring out I. So I'll make this positive, I on the outside. Two numbers that multiply to give me 8 are 4 and 2. And 4 is broken down to 2 and 2. So now I can rewrite this radical as 2I square root 2 plus 3. But remember how our complex numbers are always written. You always write the real part first and the imaginary part after. So I'm going to rewrite my final answer as 3 plus 2I square root of 2. Let's look at one more. Here we have 2 minus the square root of -4 plus 3 minus 5I. Now the square root of -4 can be rewritten as 2 I, because the square root of 4 is 2, and because it's negative, I have to bring out I. Plus 3 minus 5I. So to write our complex number, we're going to combine first the real parts, so that 2 plus 3, which is 5, and then I'm going to combine my imaginary parts. Negative 2I minus 5I is negative 7I, and this is my complex number. Now let's have a look at how we can do a couple of operations that involve these negative square roots. So here we have the square root of negative 18 minus the square root of negative 8. Before I can do anything with this, we're going to have to make sure to take the negative out of the radical, and additionally, I cannot combine radicals unless the radicals have the same number inside. So we're going to try to simplify these radicals at the same time. So first, I'm going to go ahead and make these positive and bring out I. And now I'm going to see about simplifying these square roots. So I have I square root of 18 minus I square root 8. So 18 is 9 and 2. 9 can be broken down to 3 and 3. Here's my pair, and the 2 will stay inside. 8 can be broken down to 4 and 2, and the 4 can be broken down to 2 and 2. So here's my pair, and this 2 will stay inside. So now we're going to rewrite this. Here we have the 3 that's going outside with the I, so 3I square root 2 minus 2I square root 2. Now because these square roots are now the same, I can combine what is outside. So the 3I minus 2I is 1I square root 2. So the square root just kind of tags along. Think about kind of like a variable, like as if you had x. So the square root 2 is just attached to those coefficients. Now in this next one, we have negative 1 plus the square root of negative 5. All of it is being squared. So that means that we're going to have to FOIL. Now before I go ahead and do that, I'm going to first, as before, make this positive and take out I. And because the whole thing is squared, that means that we're going to do negative 1 plus I square root 5 times itself, negative 1 plus I square root 5. And now I'm going to distribute. So I'm going to distribute this negative 1 first, which gives me 1 minus I square root 5. Now I'm going to distribute the I square root 5. And when I do that, that's going to give me negative I square root 5 plus I times I is I squared. And then square root of 5 times the square root of 5 is the square root of 25. Now just so you know, when you're multiplying numbers that have a square root, okay, in this case like a term rather that has square roots, you can only multiply what's outside with outside and what's inside with inside. You cannot combine. So I cannot multiply the I with the 5 because the I is on the outside and the 5 is on the inside, which is why I multiplied the I with the I because they're both outside, and the 5 with the 5 because they're both inside. And now we're going to see about how we can simplify this. So here we have this 1. Now negative I square root 5 minus I square root 5. Both of these have the same square roots, meaning that I can subtract what is on the outside. So if I have a negative I minus I, that's a negative 2I. And remember, the square root just tags along, so square root 5. Now I squared is negative 1, so I'm going to replace I squared with negative 1. So instead of plus I squared, I'm going to put minus 1. And then the square root of 25 is 5, and these are being multiplied. So I have 1 minus 2I square root 5 minus 5. So the 1 and the negative 5 are the real parts of my complex number. So I'm going to combine those, which is negative 4. And then the negative 2I square root 5 is my complex part. So I mean, it's my imaginary part. So that's going to go at the end of my complex number. So this would be my answer. Now you can choose to write the I before the square root or after the square root. It does not matter. but typically I usually write it before. Either way would be fine. Now over here, this should look kind of familiar because this kind of format comes from the quadratic formula, which is why I want to practice this. We have negative 25 plus the square root of negative 50, and everything is over 15. So just like before, I'm going to make this positive and bring out the I. And then before I'm going to go ahead and simplify this, I'm going to try and simplify that square root first. So we have the square root 50. Two numbers that give me 50 are 5 and 10. None of these are pairs, so I'm going to keep breaking down what I can. The only number that I can keep breaking down is the 10, which is 5 and 2. So here are my pairs, and this 2 would stay alone. So now I'm going to rewrite this using my simplified radical. So negative 25 plus 5i square root 2. And everything is over 15. Now, instead of putting everything over 15, what I'm going to do is I'm going to put every term over 15. So negative 25 is over 15 as soon as I can write. My computer is being a little slow. Here we go. So 15. And then over here, 15 as well. And now I can simplify these fractions. 25 and 15 are both divisible by 5, so I can rewrite negative 25 over 15 as negative 5 over 3 plus, and then 5 and 15 here are also both divisible by 5. 5 divided by 5 is just 1, so I square root 2 over 15 divided by 5, which is 3. So this would be my final answer. This is how to simplify that particular problem. Now you can write it like this. This is an acceptable answer. Or you can also write it as negative 5 over 3 plus square root 2 over 3i. Now let's try a couple more practice problems. Here we have the square root of negative 27 plus the square root of negative 48. So just like before, we're going to bring out I, make these positive. And we're going to see about simplifying these square roots. Now 27 is 9 and 3. And 9 can be further broken down to 3 and 3. So here's my pair, and this 3 will have to stay inside of the square root. The two numbers that multiply to give you 48 are 12 and 4. And then 12 can be further broken down to 3 and 4. So here's a pair of 4s, and this 3 has to stay inside. So now let's rewrite this using our simplified square roots. So the square root of negative 27 is 3i square root 3 plus 4i square root 3. Because these are the same square roots, we can add what is on the outsides. So 3i plus 4i is 7i, and the square root 3 just stays attached. And this would be my answer. Over here, we have negative 2 plus the square root of negative 3 squared. So again, I'm going to make this positive and bring out I. And I'm going to rewrite this so that I can multiply since this is squared. So this means that we have negative 2 plus I square root 3 times negative 2 plus I square root 3. And now I'm going to go ahead and FOIL. So I'm going to distribute this negative 2, which would give us 4 minus 2i square root 3. And now I'm going to distribute this I square root 3, which would give me negative 2i square root 3 plus I squared square root 9. And now I can simplify all of this. So here we have this 4. Negative 2i minus 2i is negative 4i square root 3. Plus, remember that I squared is negative 1. And the square root of 9 is 3. So this means that I have 4 minus 4i square root 3 minus 3. And now I can combine the real parts. 4 minus 3 is 1 minus 4i square root 3. Now remember, this is an acceptable answer, along with 1 minus 4 square root 3I is also an acceptable answer. So wherever you choose to write the I on that last term is okay. Now let's work on this last one here, simplifying this division problem. So negative 14 plus the square root of negative 12, and everything is over 2. So just like before, I'm going to make this positive, and I'm going to see first about simplifying this square root. So the square root of 12 can be broken down to 4 and 3. And 4 is 2 and 2. So here's my pair, and this 3 will have to stay inside of the square root. So now I'm going to rewrite this. So we have this negative 14 plus or minus 2I square root 3. And everything is over 2. So I'm going to put negative 14 over 2 and 2I square root 3 over 2. And now I can see if I can simplify this even better. Negative 14 divided by 2 is negative 7 plus or minus. Now here we have 2I square root 3 divided by 2. The 2's here would cancel, and so that leaves me with I square root 3. And this would be my final answer. And just like before, you can also write it as negative 7 plus or minus square root 3 and then the I at the end. Either one is acceptable. And those are complex numbers.